All right. Uh, okay. So today we can start the motion under gravity. Uh, so after finishing that, we can start a new section, which is jointed rods. And this time the paper is quite reasonable, the POMeth paper. And the problem from applications of derivatives is very similar to what I gave you last time, Friday. It's very similar to the problem in the Friday's paper. Uh, and problem 1, 2, 3 are very similar to what we did. I mean, in the class, in papers. And 11, 12, 13, 14 are also very similar to what we did in their papers. Hmm. Uh, 15B is little difficult. But other than that, I think tape is fairly easy. It's not similar to the provincial paper anyway. Yeah? Provincial paper is quite different. Right. So we'll start the motion under gravity. Okay. In this case, there's nothing new. The only difference is that uh, when something moves under gravity, the acceleration is given. Acceleration is g, and its direction is known. It's in the downward direction. In the other problems, acceleration is something unknown. If it's not given, it's unknown. Uh, and it's given, it's known, right? But in this case, it's different. Uh, Even though it's not given, usually it's not given, but it's known. You know what it is, right? Uh, so to solve a certain motion, you need two extra data only. Like usually we have 5 parameters like U, V, A, S, and T. We need 3 of them to solve a certain motion completely. But in this case, since this is G, you need two more data to completely solve that motion. That's the only difference. And here the direction is important because because in the previous cases, always the motion is in one direction, but apart from one problem we did, in all the cases, the motion is in a certain direction. So everything is positive. The VT graph looks like this or something like this. But in this case, it may be different because G is in the downward direction. Sometimes the object moves in the upward direction. So directions may be different. Therefore, you have to come up with a sign, like you have to come up with a sign convention. Hmm. It's up to you. You can take the downward direction as the positive direction, or you can take the upward direction as the positive direction. It's your choice, right? So that's the only difference we have here. So we'll do some examples. Okay. We can do the relative motion later. After actually we are doing relative motion, we can do this. Uh, relative motion is relative velocity is our next topic. So relative motion of two objects can be discussed once you know what it is. If we can do it later. Motion under gravity. Hmm. Let's do something really simple. We'll do 39. It's in page 7. Hmm. Okay. An object released from rest from a point at height h. So it's something like this. You release a certain object from this level. Sorry. Force under gravity. So using a velocity time curve or graph, show that the velocity with which it hits the ground is square root of 2gh, and show that the time taken for it is square root of 2h over g. Now, g is in this direction. You can mark that, and you can come up with the sign convention now. Now, the motion is also in the same direction, right? So, no point of taking the upward direction as positive direction. Hmm. It makes, I mean, it's no useless because the motion is also in this direction, gravity is also in the same direction. Therefore, you can take this as the positive direction. So basically, that's it. Now we'll sketch the graph. Okay. Initially, the velocity is 0. Uh, it attains some speed when it moves, when it goes down. The acceleration is constant. So you need to have a straight line to indicate the motion of that. So the gradient is g, even though it's not given, I mean, it's not given explicitly, but you can take it as g. Now the height is h. Now how many data we have? We have the acceleration, distance, or the displacement, and the initial velocity. Even though it's not explicitly given, it's 0. Right. Now you can label these, probably OAB. Now what can we do? The only problem we have is that uh, the parameters indicated by these x's are not given. Then you have to come up with two equations and multiply them to, okay, let's take this time as t. We need to figure that out. And the final velocity v. So you have to come up with two equations. So from triangle OAB, uh, h is equal to half vt, right? Then you can write something for the gradient. G is v over t. Now you can multiply those two to come up with some useful result. If you multiply them, your t will go away. Right? This side you get gh. When you multiply these two sides, you have half vt. I mean, you don't have to write everything, but for the sake of clarity, I'll include here everything, right? You can just skip these two. You don't have to write that because this t sitting in the upstairs will go away with this when you multiply these two. Now you have v squared is what? 2gh. If you cross multiply, you will end up with this. So v is the square root of 2gh. That's the required velocity. Hmm? Now we need to find the time taken for that. You can use one of those equations. Usually it's better to use this one. No. Yeah, it's better to use this one. It's okay. So we'll use two. Uh, so G is, or I mean, you can straight away write what T is. If you cross multiply, T is equal to V over G. This is V over G. Now, if you write everything under one square root, this will be G squared. So you will end up with this. Right? So it's simple. Right? We'll do one more. Something which is not that easy. Yeah? We'll do 43. Hmm. Okay, you first take this down. Then we'll do 43. In 43, okay, first you take this down. There are some corrections to be made. I mean, one sentence is missing here. 44 is wrong, right? At time t, the ball reaches the maximum height. That sentence is wrong. It should be in this way, right? 43, yeah? At time at t is equal to capital T, a ball is released from the balloon. Right? Should be like that. That sentence is missing. And then that at time t, the ball reaches its maximum height. No, that part should be erased. Huh? The ball reaches its maximum height. That part should be erased. Instead, you need to have this one inserted there. At t is equal to capital T, a ball is released from the balloon. And then draw a velocity time diagram, VT graph, for the upward motion of the ball until it reaches its maximum height. It should be in that way. Until it reaches its maximum height. I mean, draw a VT graph for the upward motion after that. I continue this. The first part was correct. Upward motion of the ball until it reaches its maximum height. In the last sentence, with respect to t, usually we don't write it like that in terms of, it should be in terms of. With respect to should be deleted in the last sentence. At time, or at t is equal to capital T, a ball is released from the balloon. Right? It's hard to make the correction because the space is not enough, it seems. Hmm. And then draw a VT graph, the next sentence, for the upward motion of the ball until it reaches its maximum height. At that point, show that the maximum height reached by the ball with respect to a maker in terms of window. Ne? With respect to අපි differentiate කරනකොට වගේ with respect to one variable. එතන with respect to point අපිට කියන්න පුළුවන් position vector එක. මොන හරි දාන්න අපි ඒ කියන්නේ expression එකක් දෙනවා නම් in terms of these variables කියන්න ඕනේ. ඒ අන්තිම වෙලන් correct නොකරත් මෙන්න මේ දෙක අනිවාර්යෙන් තියෙන්න ඕන. At time at t is equal to capital T, a ball is released from the balloon. ඊට upward motion එක අපි මේ maximum height එකට නිකන් විතරයි දාන්න ඕන. Right. Right. Okay, 4-3. Okay, first balloon starts from rest and it moves with this acceleration in the upward direction. Huh? Now, at a certain point, I mean, you don't have to draw this just for the clarity. For the sake of clarity, I'm inserted this diagram. Now, at t is equal to t, capital T, this has a certain velocity, right? Let that be v. So when you release a ball from the balloon, what happens? What's the speed of the ball? It has the same speed. Because when you say when you throw something from a bus, you should don't do that. Say the speed of the bus is v. If you throw something, it doesn't fall at the same place, right? Because if you drop something from a moving bus, it will move like this, like a projectile. අපි මෙතන මේ හරි ඉන්නවා නම් බස් එකෙත් අපි මෙතනට එනකොට තමයි මේක මේ ඔබ්ජෙක්ට් එක බිම වැටෙන්නේ එයාර් රෙසිස්ටන්ස් නැත්තම්. අපිට පේන්නේ මෙහෙම වැටෙනවා වගේ. හැබැයි ඇත්තට වැටෙන්නේ මෙහෙම. So likewise, if you release a ball from the balloon, when at that point of release, it has the same speed. After that, what happens? Now, see, this has the same speed. Even though this goes with the acceleration g over 2, what happens to this ball after that? It moves under gravity. Now, gravitational acceleration is in this side. Now, since initially it moves with the upward like acceleration which is in the upward direction, possibly in this case you can take the upward direction as the positive direction. Right. Now, what happens? Initially, now this has the same direction as the positive direction. Therefore, this acceleration is a positive acceleration. It goes like this. This is g over 2. And this time is capital T. Right? After that, what happens? The balloon goes like this. Now, what happens to the ball? It starts with the same speed, v. After that, its acceleration should be g. But g is in the other way. So since we take this as the positive direction, you can understand this as a negative acceleration, means retardation or deceleration. Hmm? Negative acceleration. Hmm? Therefore, the gradient should be negative, like this. This is g. In fact, it is greater than g over 2, so I can have a greater slope for that. So what's the point of the maximum height? Now, even though it goes with retardation, right? Still, it has a positive velocity, right? This is the point where the velocity becomes zero. That is the maximum height, right? So you have to draw this graph. Now let's take this as some simplicity. We'll see what the problem is. 43. We have to find the uh, maximum height. Okay. Maximum height means this area. Triangle OAB. So to find the area, what do you need? You need V and simple T, right? You need V and simple T. You can easily find V because in this part, you have three data, like acceleration, time, and the initial velocity. So there's no problem of finding V. Now, after that, once you know V, what V is, you can take this triangle and find T. Then we are done. You can find the area. Right? Because what's the area? Capital T plus simple T times half times capital T plus simple T times V. So we need to find V and simple T. So from triangle OAC, you can write G over 2 is V over capital T. So V is capital GT over 2. Then from triangle this ABC, you can again write an equation for G. G is V over T. So from that T is V over G. I'll replace this guy for V. V is GT over 2 over G. So these two will go away, leaving simple T as capital T over 2. Now that's it. I'll write the area here. Maximum height. Is the area of triangle OAB. Half capital T plus simple T times V. Uh, this you have to replace capital T by, simple T by capital T over 2, and this is GT over 2. You can simplify this. This is 3 capital T over 2. Which is 3 GT squared over 8. Make Purana Balana to make a Balana de Gutne. Once you know what's going on, you can simply uh, do the problem by yourself and try to do 44. 44, again, you have to do the same corrections. You do it in the same way, right? Here the balloon goes with the acceleration F. That's the only difference. 44. Again, the same corrections should be made, but you know what it is, what they are, and do problem 44. 44. Right. The graph would be something like this. A balloon moves with the acceleration f. So once it reaches this height, we don't know what that height is, a ball is released. After that, it moves under gravity. Yeah, I forgot to label the graph. Huh? You should label it correctly. Initially, okay, now you have to choose a direction, the sign convention. We can take this as the positive direction because motion is in that direction. Now, this is f. So the slope is f. At time t, a ball is released from the balloon, and the ball itself has the same speed at that time, same velocity, in fact. After that, it moves under gravity. Now, gravity is in the opposite direction. Therefore, its acceleration is negative, means it has a negative slope. Again, it's very similar. The only difference is lies here. Now, from triangle OAC, you can write F is equal to V over capital T. We need to find simple T and V. Then we can find the area. So V is simple F times capital T. Now you can go for the other triangle to find T. There also, you know, three parameters: final velocity, initial velocity, and the time taken for the motion. So from triangle ABC, you can write G is equal to V over T, simple T. So T is V over simple G. This is capital F T over G. Uh, Maximum height or maximum height reached should be the area of triangle OAB. That is half times base times height. Base is capital T plus simple T, and height is V. Now substitute these guys for simple T and simple V. Simple T is this. V is Ft. Now you can simplify it. You can pull out T. So it will make it T squared. So half, when you pull out T, you get 1 plus simple F over G. Now you can take G as the common denominator, you can get the answer. Right? Okay, we'll do 73. Usually these are not real-time accelerations given in that problem. The motion of this rocket given in the problem is like a balloon. It moves very slowly. Usually this is not the actual case. Huh? In the case of rocket, the velocity is, the acceleration is very high. Right. Uh, so in this case, a rocket starting from rest at the surface of the Earth travels with an acceleration g over 3. Usually it should be like 10g or 20g, but here it is g over 3. So initially it travels with g over 3. Right? For the first time interval 3t. So after that the acceleration is g over 2. For the next time interval, it should be like time interval. This is my first English medium class, so I had to uh, translate everything. But I didn't do them. I had one of my students. She did a pretty good job, but there may be some little mistakes there. Uh, we have to do it real quick. Like we have to translate nearly 5,000 problems. So it's not a joke. So there are some, but in the second time, like for 26 batch, I think I can correct those. It's easy to correct these, but at the first place, getting everything translated is very difficult. Uh, okay. Now, in the first portion, the acceleration is g over 3. Initially, t is 0, right? So at 3t, I mean, after elapsing a time of 3t, it attains an acceleration g over 2, right? That's what it says for the next time interval 2t. So this will be 5t. So after that, uh, its acceleration is g for another time interval t. So at 6t. After that, it falls under gravity. It falls under gravity. So time taken to reach the maximum height. That's the first part. Maximum height reached by the rocket. Time taken for the rocket to fall on the ground since fall on the ground. That would be enough. Uh, Fourth one, velocity of the rocket when it hits the ground. So it will be a little complicated. How can we do this? Okay, you can see that almost all the time the motion is in the upward direction, right? So you can take that as the positive direction. However, g is in the other direction. Now, initially, its acceleration is g over 3 for a certain time period. That is 3t. In the next time period 2t, next time period of 2t, its acceleration is g over 2, slightly greater than this, but the time interval is 2t. In the next time interval t, in this portion, its acceleration is even greater. Sorry, I have forgotten to indicate this. Now it is g only for a time interval t. After that, it falls under gravity. Now, up to this point, the motion is in the upward direction. But still, even it falls under gravity, its motion is in the upward direction because it has attained a certain speed now. Right, the Megama would do Siguru take it would any, he can still, even though it has a retardation, it moves upwards. Right? Maybe Siguru, he would okay. Now it has a certain speed now. It has attained a certain speed. Now we need to find those speeds. At the end of this motion, say the velocity is v1. Oh, we can take this v, this w, uvw, then we can go for x. After that, uh, it falls down. But still it has an upward motion, right? However, it's a retardation because it moves, it falls under gravity. Now, this is the point where it reaches the maximum height. Because all the way, throughout this motion, it moves in the upward direction. Now, after that, once it reaches the maximum height, it falls down. Now, this is where you, for the first time, you get a negative velocity. Oh, it falls down now. This area should be equal to this one. So this is the maximum height it attained. So it should fall down the same height, but if I draw it, I should go somewhere there. If I'll stop, stop the, I will take this as the, this is equal to this one. Oh, I have to write it, a little up, somewhere here. I can take the axis somewhere here. That's another option. I have to redraw it again. So we'll leave it like that. And just go beyond this a little bit. Right. Now, to find, first we need to figure out this time. I'll take it as T1. Now, to find this maximum height, the time taken to reach, time taken for the rocket to reach the ground, you need that T2 as well. Right? Now, we'll see what we need. Now, time taken to reach the maximum height. So, it is this time. You have 60 plus T1. So, you need to find T1. After that, maximum height reached by the rocket. Now it is the area of this triangle, this trapezium, and the last triangle. That means you need to find these three, because you need those to find these areas. For this triangle, you need V. For this trapezium, you need both V and W. For this one, you need W and X. For this one, you need X. Right? So after that, I think I should have, otherwise, it's hard to capture everything for the video, right? I'll take this time as, this velocity as minus y, xy, right? For some v, w dash, or v dash. Now v dash is a positive quantity, if I write it like that. Huh? Minus v dash means now v dash is a positive quantity. The minus 2 gives the 2 can positive, like that. Okay. Now, we need to find all those. Maximum height reached by the rocket. So you need to find this area. Second, third one, time taken for the rocket to fall on the ground. That means this height. This time. So you need to find T2 as well. Once you know this height, it's not a big deal. You can find this one because that height is equal to this area. That area should be equal to this one. So if you know this area, you know this area. So once you know this area, it's not a big deal to find T2. You can find it. And you know that this is G. So you have 3 data. You can figure that out. It's not a big deal. Next one. Velocity of the rocket when it hits the ground. You need to find V dash. Right? So this is how you have to work on this. You have to find V first. Because without finding X, you cannot find T1. Before finding T1, you have to find V. Then you have to find W. Then you have to find X. Then you have to find T1. After that, it's not a big deal, right? Then you can find the area. Once you know the area, you can find T2 and W. So T2 and V dash. So this is how you have to do it. Now we'll label these. It's right J. Now, from triangle AOB, you can find V. From this trapezium, you can find, no, trapezium, you can insert some area, or some letter here, K, L. Otherwise, we cannot use this G over 2. Right. Now, from triangle AOB, or OAB, you can write G over 3 is V over 3T. So it is GT. Now, from this triangle, you can find W. It is like triangle AKD. Where you can come up with those three letters, AKD. Now, from right, AKD, you get G over 2. ABC again, common in AKD, no chance. G over 2 is W minus V over 2T. These two will go away. So GT is W minus V is also GT. So if you add them up, you get 2 GT. Now from triangle, this DEL, there the acceleration is G. You get X minus W, this length, divided by T. So again, you will get GT is X minus W. W is 2 GT. So you get 3 GT is equal to X. Now you can, okay, now we are here. Now you can find T1. Using this triangle, you can find T1 because you know what X is. So I'll write it somewhere here. From triangle, this one, EFG, you have G is equal to X over T1. X is 3GT, so T1 is 3GT over G, right? So it is 3T. Now you can find a lot of things. You can find the time taken to reach, right? Its maximum height. Then you can find the area because you know everything now. This triangle plus this trapezium plus this one plus this triangle. It takes some time, but you have to do some work, but it's simple, straightforward. Now you know this area. Once you know this area, you can come up with two equations for this one. Why? G is equal to, now the problem is, you know the area because this area should be equal to this one. Why? Would it give right? So this is the distance traveled in the upward direction. This is the distance, this is the distance it travels in the downward direction. Again, it hits the ground at this point. Therefore, those two distances should be the same. Now, once you know this area, you know the area of this as well as the retardation. But the only problem you have is that the parameters indicated in the axis, along the axis are unknown. T2 dannit naha, meka dannit naha. That means you run into little problem, but still you can figure that out. You have to write two equations. G is equal to, this length is what? It is V dash. It is not minus V dash, huh? V dash. Length is digani. Mithana minus 2 na me diga deka. It's 2, right? Therefore it is V dash. So this is V dash over T2, right? So G is equal to V dash over T2. That's the gradient. You can find now, area is known. Area is equal to half T2 times V dash. So you get two equations. If you multiply those two, you can find V dash. Once you substitute that value for V dash, you can find T2. Right? Probably you can do it now. So the time taken, part A. Maximum height is 60 plus T1. 60 can make 3T plus 2T plus T plus T1. T1. It is 90. You can find the area now. It's not a big deal. Now you can find this area. Should be able to do it now. Now that area is equal to this area. Then you can write two equations for this and figure out T2 and V dash. But I'll do that for you, but first you try it out. Huh? So this is the area of this. I straight away directly substituted those values. The expressions obtained for V, W, and X. Is little too much, right? Let me write everything in terms of X, Y, and sorry, V, W, and X. Then I'll substitute. This 1.5, this 2.5. So altogether 4. 4 plus 3 is 7. 7 plus 4.5. 11.5. Now that area is equal to half T2 times V dash. And on the other hand, G is equal to V dash over T2. Time taken for the rocket to fall the ground. So for that, 9T plus T2, you need that T2. And then you need to find V dash. You don't have to redraw this again. Redraw this. I'm doing it because, for the video, otherwise people will get confused since they don't have the graph at their disposal. We have this. This is 23. These letters are GHJ. You don't have to redraw this. Right. Now for this, you write two equations. The first is the area. Is half times V dash times T2. This is 23 G2 squared over 2. These two will go away. The second thing is that G is equal to V dash over T2. So if you multiply these two, you get 23 G squared T squared. This is equal to V dash squared. V dash quantity V dash squared. These two will go away. Now this is the square root of this. From this row. Yeah. So 3 GT. Now you can plug in that to find, plug in it here. No, here, it would be better. So T2 is V dash O G. Part C, the time taken. 90 plus this. The velocity is this one. Right. Then you can try 67, 67, 67. Okay, in this case, the balloon starts to move vertically upwards with the wrist with constant acceleration g over 8. Just to understand what's going on, okay. This is g over 8. After time t, time period t, an object is released. So say, for example, the velocity of the balloon is v. The velocity of the object is also v. After that, the balloon moves with an acceleration g over 4 for some time interval. The time interval is t over 8 for a short span of time. So t plus t over 8. At this time, it get burst. So so it will be like this, huh? It bursts at that time. So after that, it falls under gravity. This falls under gravity at this point. This falls under gravity after elapsing t plus t over 8. Now, if you draw the Vt graph, it should be like this. Now, gravity is in the downward direction. You can take the upward direction as positive direction. Now, initially, the acceleration is like this, g over 8 for a time period t. After that, this is g over 4. The time interval is t over 8. Right? After that, it moves under gravity. We have to find the time instant where the speeds are equal, not the velocities. Huh? Velocities cannot be equal because after that, these two lines are parallel. Velocities cannot be equal. But speeds means their magnitudes should be equal at some point. Say somewhere here, this height should be equal to this height. Hmm? Say this is x, this is minus x. I should have drawn it a little larger. Otherwise, I cannot easily indicate them. Hmm? Can I draw it? Shall I erase it? Hmm? I'll draw it again. Otherwise, it's too congested. Hmm? Let me draw it somewhere here. Initially, the acceleration is g over 8 for some time period, simple t. For the next time period, t over 8, which is relatively a small time interval, the acceleration is greater. It is g over 4. After that, it falls under gravity. the ball or the object released from the balloon, it also falls under gravity. In fact, it should go through this point. Because this is G over 8, this is T over 8. This also G. These two are parallel, no? I'm sorry. So the velocities cannot be equal. However, at some point, their speeds can be equal. Probably somewhere here. This is X, this minus 6. We need to find this the time taken for this to happen. So we need to find T dash. So how can you do that? This is G. This is also G. Try to do it. First, anyway, you have to find V, right? It's not difficult. You can find V. Then W. Find V and W. You can easily do that. From this triangle, you can easily find V because G over 8 is V over T. Right? I'll label these. Using this triangle, you can find V. Right? Then, for the balloon, you can, using A, B, C, D, or you can take this as E. Using triangle ADE, you can figure out what W is. This one. After that, it's a simple thing after that. After that, possibly you can show that the time taken out, or this one reaches its maximum height, the object, exactly at this point. For this one also, this is T over 8. You can show that. After that, for this motion, you can write an equation. You can write another equation for this one. Using that, you can figure out T dash. So from triangle OAB, V is, sorry, G over 8. Make distances ahan name because distance can distances and by own just the time. So here you get V as GT over 8. Now using this triangle, you can find W. When you multiply, you get GT over 32. You can add these two. And in fact, we need to find this time as well. The time, those two are equal, it will be, but you take it as T dash. I'll take this as T double dash. So T dash means for the object, for the ball, or the object released from the balloon, from triangle ABC. G is equal to V over T dash. T dash should be equal to T over 8, but we need to justify that. We have to show that. It is V over T dash. Now V is GT over 8, but T dash. So T dash is T over 8. So that means when the balloon reaches its maximum maximum speed, the object reaches its maximum height. Now for this portion, T dash is the same for both objects. I make a method, but I have indicated it like slightly error with slight error because at the beginning we don't know exactly what it is. Hmm. Now we know that these 2 points coincide. You can write something for this as well as this. In both cases, X will appear. Then make X the subject from both the equations and cancel it. Up your speeds are equal current. Not the velocities. Velocities cannot be equal. They are parallel. So, you don't find a time instant where the velocities are equal. You need to find T double dash. That's all. Okay. I mean, after that, it's just a piece of cake. You apply something for this one. I have used letters up to E. I'll take this as FG. Then IJ. I don't use I, JK. Now for triangle DFG, you write something for G. G is equal to this gap over T dash. Write this one, write something for this triangle as well. Then find T dash, T double dash. That's all. Because only unknowns you get are X and T double dash. Hmm. Don't find the area because we don't have any clue. We don't have a clue about the distances traveled. And we don't need that. You simply compare this triangle, not compare, but you write some, obtain a formula for these two triangles, formulas to those two triangles. Then it's a piece of cake after that. Now we have to find T double dash, right? So from triangle DGF, you can write G is equal to this gap, W minus X over T double dash. So GT double dash is equal to W minus X. So X is W minus G double dash. W is, you have figured that out. W is this. But for the time being, we'll have it as W. Hmm. Now write another equation for this. From triangle CJK, you have G is equal to, now this is X, X over T double dash. So from 1 and 2, you can eliminate X. GT double dash is equal to W minus GT double dash. That's why you get 64 in the downstairs. So these two will go away. No, that's not the answer. Is, the time taken is this. Simple T plus T over 8 plus T double dash. Now take 64 as the common denominator, right? You get 64T plus 8T plus 5T. 77T over 64. Then we'll do 82. You first try it. Huh? It's like this. A particle is projected horizontally. Capital T is a constant. Draw separate velocity time graphs for the vertical and the horizontal velocity components of the particle. It's kind of a projectile, but we haven't gone through the projectiles. But the horizontal velocity component is constant because if you ignore the air resistance, no force is acting in that direction. Therefore, the horizontal component is extremely easy to graph. Right? The horizontal component remains constant. I mean, it is like this. Throughout the motion, it is like that. This for horizontal motion. This for the vertical motion. Initially, the velocity is zero. You can take this as the positive direction. G is also in the same direction. It's like that. Then try to answer those questions. I've done? No. Okay, let me do it for you. So I'll redraw these two graphs. Right. As I told you, when you project an object from height h above the ground, so you will see something like this. The horizontal component is constant throughout the motion. Hmm. Let the time taken for the motion be simple t. This is the velocity. Hmm. Uh, so this for the horizontal motion. So horizontal component. Huh? Axis में mark करना मैं unit टिक डाला. Right. Here the initial velocity is zero. Initial component is zero. And it's like if you the motion is like this. If you drop something, right, it falls under gravity. The vertical component is exactly the same. Hmm. So it starts from zero. Acceleration is g. Again, the time taken is simple t. Say this is v. Now, if the particle lands at a distance, now that's where you have made the mistake. So what's meant by that? 3 over 2 gt squared. What is that? The distance from the point of projection. May diagram again the So where is it? What's that particular distance? It is this one. It's not indicated in the graph. That's the distance, right? This is the point of projection. This is where it lands. Hmm. Let that be d. D is 3 over 2 gt squared. Now, we have to show that the time taken for it to land should be capital T, and h is half gt squared. How can you do that? Okay. We'll label this. I'll take this as O dash. Now, we'll see. We can possibly write everything in terms of simple t. Right? If you know simple t, you can easily find the height using because this is the height, the area of this vertical motion, or I mean, area of the VT graph, which indicates the, not the vertical component, gives you the height, right? Make any height h. So you need to find v in terms of simple t. Later we can figure out simple t. We have to show that simple t is equal to capital T. Right? So the only way to bridge those, because capital T is in the other graph. So the only way to bridge simple T and capital T via this one. Because d squared is h squared plus this, the horizontal, or this displacement. I'll take L. So d squared is h squared plus L squared. Right? H is this area, L is this area. Right? Okay. Uh, so we have to eliminate V. So we can write something for this from triangle or for the triangle. It's both are all right. O dash DE. You can write V. Sorry, you can write G is V over T. So V is GT. Because without V, you cannot find the area. So sorry, with V. So you have to replace V, we have to find V in terms of T. The first thing you need to do is to find T, simple T. Once you know simple T, right, you can easily find H. This is H, right? If you say, for example, if you show that after showing that simple T is equal to capital T, you can easily find the area. Area is H. Look, H is, this was the part of the answer, half times this one. Say we have already shown that this is equal to capital T. So base is capital T. Height is V, which is G times capital T. So that is half GT squared. So it's simple. We have to show that. So the only difficulty is to show that simple T is equal to capital T. Right? That's the only difficulty. How would you find it? Now you can easily find the area. This area, it is in fact H, right? So we'll find, so H is equal to half simple T times V, half T times GT, which is half GT squared. Now you can use this. Right? This is the like this distance from the make have indicated this as D and D is equal to this. No. Again, diagram make details applied that's the key. You can apply Hamilton Pulankaran because there are only 9 things that you need to know for the entire applied math paper. Equations of motion. Uh, Principle of conservation of linear momentum, conservation of energy. I equals delta mu. Then how to take a moment, how to resolve forces. Likewise, there are altogether 9 concepts. Anybody can do that. But sometimes people, like when you do a problem, you can go through probably 70% of the problem. After that, you get stuck. Because you get stuck because you need to draw a diagram there. But people find it a little lazy. Oh, why should I draw a diagram? It takes some time. If I waste time on drawing, sketching something, I cannot probably complete the paper. Apara the time make mark scheme the mark scheme make why is it's not there in the mark scheme? Because mark scheme make hadarni ඔක්කොම දැනගත්තා පස්සේනේ හදන්න. ඒක හදලා ඊට පස්සේ ලස්සනට ලියනවා මාක් ස්කීම් එක. ඒතර එයාට හිතන පාර්ට් එක ඕනේ නැහැ ඒකේ. It's right. ඒතර හිතන පාර්ට් එකට අපි ඒක ඇඩ් කරගන්න ඕන. because otherwise ඒ කියන්නේ දැන් ප්‍රශ්නේ උත්තරේ දන්න කෙනෙක් ලියන විදිහ දන්නේ නැති කෙනෙක්ගේ පොඩි වෙනසක් තියෙනවා. ඒ ඩිෆිකල්ට් පාර්ට් එක ෆිගර් අවුට් කරගන්න ඩයග්‍රෑම් එකක් ඉන්සර්ට් කරගන්න වෙනවා. ඒ ඩයග්‍රෑම් එක අඳින්නේ නැහැ ගොඩක් අය. ඒක තමයි හිර වෙන්නේ. ඇප්ලයිඩ් බැරි හා පුළුවන් හරි වෙන්නේ මේ ඒකෙන්. right right okay now you use this d square this because you know everything in terms of t simple t because this area is like this l is square root 2g t times simple t, right? Now use that. D squared is equal to h squared plus l squared. D is known, it is this. So 3 over 2 hold on. Yes. H is this. L is the area, right? The horizontal distance traveled by the object is the area, sorry, is the L. L is t times this. Sorry, the square of that. Now this is 9 over 4 g t squared, 1/4 g simple t to the power, sorry, 4. This 2gt vt. Ah, it's wrong. Square root 2 times gt should be in this way. Sorry. Therefore, it should be like this. Because otherwise there's a problem with dimensions. And now 2 times g squared, t squared, simple t squared. Now you can get rid of this also g squared. Sorry. This also g squared. So you can get rid of this. Now multiply everything by 4. So it's a simple quadratic equation. You take everything to this side. Now to the other side. Plus 8 capital T squared, simple T squared, minus 9 capital T to the power 4. You can factor this. Uh, 1 times 9 minus 9 is minus 9. Minus 9 can be written as a product of two numbers. Right? 9 times 1. One number should be negative. Right? This. But the sum of these two is 8. So you have to choose this pair. Or you can straight away factor this. Right? Minus. Oh, sorry. Now take this pair. T to the power 2 can be pulled out. From this, you can pull out capital T squared. You get simple T squared minus 9 plus cap this. Now you can factor this. So we have two solutions. Huh? Capital T cannot be negative. Why? If capital T is negative, the velocity is negative. Capital T cannot be negative. Huh? So T is T minus T. This will give you like uh, imaginary roots. So since T is positive, you have to go for this one. Now once you know that, you substitute it here. So using 1, H is half G capital T square. Right? මේකගොල්ලෝ ගත්තේ නෑ අනිවාර්යෙන්. ඒක තමයි බැරි උනේ. පොඩි සිම්පල් දෙයක් මිස් වුණා. ඒ කියන්නේ සිම්පල් දෙයක් මේක සිම්පල් නැත්නම් මේක තමයි ඩිස්ටන්ස් එක. Probably you have taken this as a distance. ඒක තමයි වැරදි. හරි. ඒ key point එක ගන්න ඕන. I'll give you a similar question. Huh? This is a past paper question. do after this, do 58. I won't do that for you. You do it. Huh? 58. It's very similar to this. end of July වෙනකොට සිලබස් ඉවර කරනවා අපි. ඒ කියන්නේ එහෙම නැත්නම් අර අගදී කවර් කරන sections වලට ඔයගලන්ට exposure එක අඩු වෙනවා. ජුලයි වෙනකොට අපි කොහොමද ඉවර කරමු. Except one section that is permutations and combinations ඒක අන්තිමට කරමු. මොකද ඒක කලින් කරාට it's not related to the other sections. ස්ට්‍රැට් එක සිංහලෙන් කරේ ඒක ඕනනම් අපිට කරන්න පුළුවන් after July. ස්ට්‍රැට් එක ආයෙ කරන්න බෑ ඊට කලින් after July ඒ දෙක ඕනනම් කරමු. නමුත් July වෙනට අනිත් ඔක්කොම ඉවර කරමු. නමුත් ස්ට්‍රැට් එක දැන්ට ඔයගලන්ට වැටලා තියෙනවා නම් if you have understood it at least you have some understanding that's enough for the time being. ඒකට මම සිංහලෙන් කරේ ඉතින් ඉංග්‍රීසි වලින් ආයෙ කරමු. මේක terms එහෙම පොඩ්ඩක් කරු නැති වෙන්න පුළුවන්. සමහර අය මට කිව්වා. so after July අපි ඒක කරමු. ආයෙ ඒක ඔප්ෂනල් ඒතර. ඒක already ඒක දන්නවනම් එන්න ඕනේ. ඒකයි permutations and combinations. ඒ දෙක විතරක් ඉතුරු කරලා අනිත් ටික කරමු. permutations කලින් කරන එක පාඩුයි. ඒක අගදි කරන්න ඕන. ඒක පොඩි section එක like it takes only 2 days. ජුලයි වල ඉවර කරන්න ඕන. මේ පාර අපේ papers වල ගණන් තමයි ගොඩක් ඇවිල්ලා තිබුණේ. ඒ කියන්නේ පොඩ්ඩක් numbers එහා මෙහා වෙලා exam paper එක ඇවිල්ලා තිබු ගොඩක් ඒවා එහෙමයි. සමහර එහෙමත් ඇවිල්ලා තිබුණා. ඔයගලන්ට මම Friday දුන්න paper එක ගන්න එහෙම තිබුණා. ඒකේ පොඩි එකක් වෙනසක් එක්ක ඒ numbers එක්කම තිබුණා මේ පාර exam එකේ 14B. ඉංග්‍රීසි medium class එකේ paper එක එනවා අඩුයි කට්ටිය. discussion එක සිංහලෙන්ද තියෙන හින්දා දන්නේ එහෙම කරන්නේ. ඒක මට පොඩ්ඩක් කියන්න feedback එකක් දෙන්න. ඉංග්‍රීසි වලින් මොන්න මට එහෙම කරන්නත් පුළුවන්. හරි. ඒ කියන්නේ ෆීඩ්බැක් එක දෙන්න හැබැයි නැත්නම් මම දන්නේ නැහැ මම රීඩ් කරන මට ඒක ලීසියට එකපාර කරන්න පුළුවන්. ඉංග්‍රීසි වලින් ඕන එක්ස්ප්ලනේෂන් එක ඒ මට වෙන දවසක කරන්න පුළුවන්. right okay. අද ඉන්ටර්වල් එකේ ඔයගලන්ට එළියට යන්න පුළුවන්. for the first time. පොත්තර යන්න බෑ බෑග්ස් වලින් යන්න බෑ හැබැයි එළියට යන්න පුළුවන්. දෙවොන් හරි කොහරි ගිහිල්ලාවට කවන්නේ. දෙවොන් හරි වෙන තියෙන්නේ. ඒවට ගිහිල්ලාවට කවන්නේ. හැප්පෙන්නේ නැතු ගිහිල්ලා ඉන්න හැබැයි. අපි ඉන්ටර්වල් okay after the interval we'll start jointed roads. So from next week onwards, abhi jointed roads karna with like there are two parallel sessions. Jointed roads and relative motion. So pod deka karangende veya. Relative motion to venika karange. Right. So we can have a break now. Once we finish 50, take a break. How long do you need? They asked for 10 minutes. I'll give you 30 minutes. 30-minute break. Huh? 11:50 or teacher hogi. Hope everybody is here. Oh, right. So special quotes by politicians. Uh, Ma ubage palake anuva, ma ubage sevake avivi. Who told that? Huh? Ma ubage swami, ma palake anu, ma ubage sevake avivi. SWRD Bandar Nagar. Right. And there's another politician who told something like this. Ma janadpati tumagi, serupudika thambala, suppa bunda kevudi. Suppa, serupudika thambala. Subundat kevudi gila, kivu amudi gene kiri. Name Gracia Ritan Namarini, Yatama Media Minister, A.J. Ranasinghe, Passet Serepusu Kilaga Tekaduna, just a ego election at Illune. Usaram Miti, Netherdi, Usaram Security Mitnam Kamkaru, Sajid, Yeri, qualification at the Gudak Kidno. There are two types of vacancies. One is security, the other is labor. So there's no way to divide those groups. They divide those people into those groups. So Usai security, midterm come kar. Api me ki pav chikarna. Ek hai ki. Again, a bit of problem में गुड़ा क्लीसी करगन to pull. We can make the problem much more. I mean, uh, easy and great deal. Like since others, while others are struggling to do this problem, we can do it with real ease. Once you use that Sajid Premadasa method, SP method. That's why they are in the fourth line. You have SP method. That is the SP method. You can straight away write the equations without, I mean, thinking too much, without doing any process. So without figuring out the distances, you can straight away come up with the moments. So that is SP method, or Sajid Premadasa method. Okay, now we'll start this. This is, you get this problem in, you get this question in problem 15. One part of this is jointed rods. The other is Bose notation. The specialty of this problem is that you can complete this in real quick compared to the other questions. You can finish this one very quickly. In particular, if you use that method, Sajid Premadasa method. Right? While other students are struggling, you can do it in real quick. Right. Now, in this case, you jointed rods means this. If you take a like some device like this, even scissor, a pair of scissors, the joint you have here is, I mean, it's a jointed, I mean, there are two rods in fact. They are hinged somewhere here, right? So it is a smoothly hinged joint. This kind of hinge, but smooth hinge, it can rotate in a certain plane, like our knee, for example. It's like this. It's a jointed rod. You cannot move in like in every direction like this one. Uh, you can move those arms in a certain plane freely. So that's a jointed. That's a smooth joint, right? It's like if you want to manufacture something like that, it will be something like this. You have there's a whole like thing. You use a brass. I mean something made up of brass like this, and you inserted it there to minimize the friction. Uh, but usually in problems, you don't draw it like that. Instead, you simply draw it by two straight lines. Now, this is a smooth joint. If you want to analyze the forces acting at this joint, you can separate these two. But usually you can separate these two when nothing, I mean, third one is not attached to this. Like if you have three rods, then you cannot remove that. because we don't know how exactly the forces are acting because it is too complicated. If you have something like this, you don't remove them. You leave it as it is. But if you have just two rods connected at a joint, to analyze that the forces acting at that particular joint, you can remove it like this. Now, since the joint itself is stable, the like the force acting on the first rod by the second rod, say it is this, then the force acting on the second rod by the rod up there is exactly equal and opposite. Because stable enemy like this. Hmm. Now, uh, the exact directions may be something like this. Now, if you have the forces in this fashion, it's hard to resolve them. You can resolve, like this is P cos theta, vertical component is P sine theta. Like in coplanar forces, you can resolve them. But it's difficult. In particular, when you take moments, it will be extremely difficult if you have this setup. Therefore, you go a further step and write this as horizontal and vertical components because almost every other force is either vertical or horizontal. In particular, the weights are vertical. Hmm. Probably the strings attached to that are horizontal. Therefore, it's easier to have it like this. Therefore, instead of this, we usually go with this setup. Now we'll see how the forces are resolved. Hmm. It's easy because everything is vertical or horizontal, so it's easy. If you want to resolve them horizontally, how many horizontal forces are there acting on this rod? X, T, and X1. So these three forces are vertical. Hmm? But you can you can resolve forces if it is a free rod, free from both ends. If you have something like this attached to, like, say, you have forces like this, then you cannot resolve because we don't know what forces acting at this point. That's completely unknown. Say something, say three rods are attached to this point, then you cannot resolve because we cannot resolve because there are some hidden forces there, right? So there are some forces, you can resolve it if you know the exact forces acting on this rod, but we don't know what they are. There's no way to figure that out because you cannot remove them. Hmm? In that event, you cannot resolve, right? Later, I'll give you the restrictions you have, right? For the time being, you resolve the forces because it's a free rod. So you can resolve. So T is in that direction, X1 is in the opposite direction, this is also in opposite direction. So easy, right? If you want to resolve it vertically, how? There are three forces. Y is in the upward direction. These are in the negative directions. Y1 minus W. Easy. Unlike the cases you get in coplanar forces, this is so easy. I mean, you don't have to even resolve it. I mean, you don't have to take the horizontal or vertical components. Almost all the time you get something like this. Now, when it comes to moments, it is difficult now because you have so many forces. Sometimes four, sometimes five. Hmm. So if you take the right. Now, this is little difficult. We take the moments about A. Hmm. So when you take moments, you can ignore these two because the perpendicular distance to these two distances to these two forces are zero. Now, say this is the angle that this rod makes with the downward vertical direction. It's theta. So this is also theta. Now, if you take if you want to take the moment about A, there are four forces. Now, for example, the perpendicular distance to T1 is this distance. Perpendicular distance to x1, x is this distance. Perpendicular distance to W. If you extend this line, sorry, this is the distance. Similarly, the perpendicular distance to Y is like this distance, right? Now, if you take the moment about A, you have to consider three things. First is the direction. Second is the magnitude of the force. Third is the perpendicular distance to the force. Now, if you take it in this direction, say T is positive, the distance is this. So how do you figure out that distance? A is if you take this triangle, A is the hypotenuse. This gives you the perpendicular distance. So with respect to theta, this is the adjacent side. So it is what? A cos theta. It is A cos theta. Now if you take W, the sense is positive. It is in the positive sense this way. The magnitude is W. The perpendicular distance is this. Now in this triangle, I mean, this is equal to this. You take this length. This is equal to this. It's a rectangle. Or you can take this length by taking this, assuming this angle as theta. Or you can simply take this. Now, if you take this triangle, this is the hypotenuse, this is theta. What we are looking for is the opposite side. It is A sine theta, right? Now again, go for x this way. It is minus x. Now, if you extend x, you find that this is the perpendicular distance to that. So what is that? If you take this bigger triangle, the hypotenuse is 2a. So you're looking for this length. So this angle is theta. Therefore, this is the adjacent side. So you have 2a cos theta. If it is adjacent, you go with cos theta. If it is the opposite side, you go with sin theta. So this is 2a cos theta. Now, finally, this one, y. If you take this sense, it is negative. It is in negative sense. It is in the opposite direction. Magnitude is y. This is the perpendicular distance. So if you go for this triangle, this is theta. This is the hypotenuse. So you want to find this, this length. Because this, if you extend this line, the line of action is this. So you have to find this length. This is 2a, this is theta. So you are looking for the opposite side. So it is what? 2a sine theta. Hypotenuse is 2a sine theta. Now look, always, okay, in this case, there are two terms with which cosine theta is attached. Cosine theta is what are those forces? T and X. What is T? T is this, X is this. Both are horizontal. What about the forces with sine theta? They are W and Y. This is W, this is Y. They are vertical. Right. Now we will go for this shortcut method, SV method. Right? SV method says this. Now, if you take this force, it's a vertical force. This is a horizontal force. What's the height of this force? Height. If you lie down, the height is 0. Right? Therefore, this is a miti force. So, miti ke only under miti short. Short ke liyan tall and short liyan he liyan fulani. But him never ki usa miti ki lagi him dan do. Make a miti ga. Make usega. Others you lose that the spirit of what he has said. Tall and short ki नहीं. උසලම් security මිට්නම් කම් කර. මේක security. යම් සිද්ධාන මෙහෙමත් දාන්න. මෙහෙම දාමු only security. මේක කම් කරු. ඒක ඕනෙමයි හැබැයි මේක ඉංග්‍රීසි වලින් කියන්න බෑනේ කම් කරු ලේබල්. ඒකට හරියන්නේ නැහැ. ඒතකොට you miss the whole story there. ඒක හරියන්නේ නැහැ. ඒතකොට මේක පටන් ගන්න මොන අකුරින්ද? සයන්නින් සා. සියන් නමද කරන්නු. එකයන්නේ. ඔගොල්ලෝ ට්‍රිග් ෆන්ක්ෂන්ස් වල නිකන් සද්දේනේ ගොඩක් තියෙනවා. සයින් සෙක් මේකෙන් පටන් ගන්න තුනක් තියෙනවා. කොසෙක් කොට් කොස්. ඒක අපි ප්‍රධාන මේන් ඒවා ටික ගන්නනේ. එතකොට මේක සයින් security can sign conquer can cos. So that means for the horizontal forces you attach cos. For the vertical forces you attach sine. Thank God to right. Thanks to Sajid Premdas, we have a new method. Now it's extremely easy, right? You don't have to like draw these lines and stuff to find the to take the moment. Look, we'll go for this one now. Right. We'll take the moment about A. I think this is the same as that. Okay. Now, the perpendicular distances to these two are 0. Now, okay. Now, there are 4 forces. If you go with this direction, T is positive. If you go with, this is A. I have forgotten to write that. If you go with W, it is in the positive direction. If you go with Y, it is in the negative direction. If you go with X, it is in the negative direction. It's a stable system, therefore it is 0. Now, for T, you have to go a length of A to meet X. Right? That length you need to go along this rod is A. Is it meteo horizontal or vertical? Medium come means kindly in cos, right? Cos theta, cos alpha, sorry, cos theta. What about this one? Again, you have to go a distance of A along the rod to meet this force, and it's a vertical force. Vertical means sine. Security, sine. Now go for this. You have to go a length of 2A to meet this. It's a vertical force, therefore sine theta. For X, again, you have to go a length of 2A, and it's a horizontal force, it's cos theta. Look easy. You don't have to spend time and you don't have to process anything. And මුලින් මුකුත් කරන්න දෙයක් නැහැ. Adjacent side, opposite side කියලා මොනවද හිතන්න ඕනේ නැහැ. ඒක ඔයගොල්ලන්ගේ mentally ඔයගොල්ලන්ට ගොඩක් stamina ඉතුරු කරගන්න පුළුවන් paper එකේ. එකක්. අනික you can do it real fast. We'll do this. Again about A. The way අපි මේකේ system එක ගන්නනේ. There are 2 rods in that system. Now if you take about about A, there are 1, 2, 3, 4 forces. If you take, there are some forces here, but we don't know what they are. W in the positive direction, T in the positive direct sense, 2W, they are in the same line, 2W, positive, X is negative. Y acts along the same point, right? Because this line of action goes through A. Therefore, the perpendicular distance to Y is 0. So you don't have to include that. Now, for this W, you have to go a distance of A. The rod makes an angle alpha with the downward vertical direction. So it's a vertical force, therefore sine alpha. Vertical means tall. Tall means security. Security means sine. It's labor labor come cos. Right? Now for T, you have to go A, 2A, 3A. If it's horizontal, when you move along this rod, you have to go this length, 3A. 3A, it's a horizontal force, cos alpha. even though you have to go a distance of 3a to this, in the first 2a, like you go away, but in the third one, you go in the reverse direction. You come closer to a. If it, therefore, you don't have to take 3a. Both of them are in the same line, right? Same line. The line of actions of these two are the same. Hmm? Because with the 3a now a plus a minus a. Because here you go in the reverse direction. You come closer when you move along this one. If it's vertical, like this way, you go back. Therefore, don't take 3a, it's a. Since it's vertical, sine alpha. For x, a, altogether 4a. Because if it is a horizontal force, you go away when you move along these two rods. 4a, since it's horizontal, cos alpha. You don't have to think too much. Hmm? Right? Okay, you take that down. We have to come up with those restrictions. I tell you, so there are certain restrictions like you cannot take moments all the time, and you can resolve forces all the time. Once you figure that out, we can do problems. There's only simple note we have to write, then we can do problems. That's all. Theory is over. Section is over. We have to do some examples. W. Right. I think some of you have little difficulty here because in this case, when it comes to 2W, we have to go a distance of 3A to meet that. Right. However, in this case, it is 4A. With X, if you take a horizontal force, say it is here, so this is the distance. Huh? If you move 2A along this, this is the perpendicular distance to that horizontal force. If you come to this place, this is the perpendicular distance. So you can see that when you move along these roads, the distance is increasing. But in this case, when it comes to 2W, it's a vertical force. If you place the force somewhere here, this is the distance. When you move another A, the vertical force will move to some place like this. But in the last distance of A, with the shape you have, you come closer to A here. මේකට ගිහිල්ලා ළඟට එනවා. So it is like 2A minus A, even though it's an A. Right? එක 3A වෙනුවට A ගන්න. ඒ කියන්නේ this one has a negative sense because ඈත් වෙලා ළඟ වෙනවා. It comes closer in the last portion. And you can see that W and 2W have the same line of action. Therefore, the perpendicular distance from A to this point is A to this force is the same as the perpendicular distance from A to 2W. Right? එහෙම වුණාට vertical force එක ලඟ වෙනවා මෙතනදී. Effectively it is not 3A, it is A. මම ඒකින්ද තමයි මේ problem එක කරේ. Right? In the other cases, it may not lead to any confusion. That's the only place it may lead to some confusion. That's why I want to do that for you. Now, now these are the limitations we have. If you have a rod or combination of rods, like couple of rods, possibly, this is an example for that. It is free from both ends. Sometimes you can call it as a free rod. So in that event, you can resolve forces in any direction, like horizontally and vertically. At the same time, you can take moments as you wish. Usually at endpoint, so the center point. You can take 3 moments as you wish. But in this case, if a combination or a particular rod is attached to one end, like this, and we don't know how to figure out the forces acting at that joint, then you cannot resolve. Why? There are some unknown forces. Right? If you resolve, you need to know all the forces acting on that rod. So here we cannot resolve. So that is out. We cannot take moments, because if you try to take moments at this point, there are some unknown forces. We don't know what to do with them. Even at this point, you cannot take moments. But there are some unknown forces. But if you take moment at that particular point, since the perpendicular distance becomes 0, even though they are unknown, they won't appear in the equation. Therefore, in that event, you can take moment about the point at which the other parts are attached to that. You can make point taking detach current very point taking current pull moment. That's the only thing you can do if you have some part like that. If you stick to these 2 principles, you can do any problem with much ease. It's not difficult. Right. Now we'll do examples. I'll erase this. We have to do something about symmetry, but we'll do it later. 2W. A is hinged uh, to some stationary point, to a fixed point. Uh, Sorry. Now, okay, first I'll explain you what the purpose of going through these type of problems. Now, okay, this is the joint, usually a joint has a shape like this. Sorry, this way. You have something made up of brass to ensure that there's less friction. Now, without knowing what kind of a force acting at this point, we cannot design this brass thing, the object made up with brass. So we have to make it with so that it can withstand a certain force. So I mean, engineer should come up with that design. Usually, we don't do the calculation for something exist. Say we want to come up with some, we want to construct or we want to manufacture something like this. So we don't know what kind of a joint we should come up with, how we can manufacture that. So we need to first find the forces acting at this joint, what the magnitude of the forces. Then you have to design this one, or you have to buy it from somewhere, so that the particular object can withstand that force. ඒකෙදි කැඩෙන්නේ නැති වෙන්න තියෙන්න ඕන. Usually we use brass there because otherwise it might get corroded. So, so usually brass is made okay. How it's an alloy, right? Which metals would you use to come up with brass? You're learning chemistry, so you should know what the two metals you compound to come up with that brass. One is copper, the other is zinc. 66% of copper and 34% of zinc, usually. It has very, I mean, less friction and kind of anti-corrosive, it don't get corroded, right? Unlike the other metals. And it's cheap. Okay. Now, we want to, okay, show that beta is pi by 4, and then we have to find the vertical and horizontal components of the reactions at joint B, and we have to find tan alpha. So you have to I mean, detach this joint. Now this is beta. Now you have to come up with the forces at this point. Usually one is horizontal, one is vertical. Now since this force is in the to the right hand side, uh, you can have it to this side. But if you have no clue to which side it is acting, in a complicated diagram, you can mark it to any side. It's okay. It may be negative, but we don't care. But here we know for sure it should be in this way. And the other force, vertical component, is in the upward direction. Here, this is y, because the other one should be exactly opposite to this one, because the joint itself is stable. It's not moving. Now you can resolve, right? You can resolve forces and find x and y. But before that, you have to figure out beta. To find beta, you have to take moments. When you take moment, you get cos beta and sin beta everywhere. Using that, you can figure out tan beta. Now you can take, considering the stability of BC, right? You can take the moment about B. It's a free joint. You can take it about C. But if you take the moment about C, uh, X and Y will be there in the equation. But we need to figure out beta. To do that, you have to take the moment about this point so that you can get rid of both X and Y. If you resolve, you can find X and Y. But before that, you have to find tan beta. You have to find beta. So to find beta, you have to get rid of X and Y. Therefore, the only option you have, because if you resolve, it will appear, one of those will appear in the equation. If you take the moment about any other point, they will appear. The only thing to get rid of these two, you have to take the moment about B. So you can find beta. After that, by resolving the forces, you can find X and Y. To find alpha, again, you have to come to this rod. Here, the only thing you can do, look, it is not detached from both ends. It is attached to this, attached to a fixed point via this hinge. Therefore, the only thing you can do, because there are some forces acting at this point. Hmm. Therefore, we are not interested in finding those. Therefore, take a moment about this point. Hmm. Then it will give you alpha. The only thing you can do is that you cannot resolve forces. You cannot take moments about the other points. You can just take a moment about this point. That's the only thing you can do. But here, if you want, you can take moments about these points, but that those will not give you any useful result. And you can resolve. But theoretically, you can do them. It's not wrong. You can take moments about these points. But in this particular problem, since we need to find beta, it's better to start off with that. Take a moment about this, then resolve forces and find x and y. Finally, find alpha by taking a moment about this point. Hmm? This is like examination paper problem. Huh? This is not easy problem. Something similar to that. Hmm? Okay, now we'll take the moment about B. So we have the Sajid Premdas method. It's much easier. And the lengths are, I forgot to give the lengths. Right. Okay. While others are struggling, we don't have to struggle. It's just a piece of cake. You take, it's about B. Okay. This one is positive. This W is positive. What's the distance? You have to go to a distance of 2A. It's a horizontal force. Mitiga. Mitiga cos kamkar kind important cos beta. Now this one, it's in the negative sense. You have to go a distance A along the rod, and it's a vertical force. Therefore, it is sine beta. Hold on. It's 2W. 2W. Yeah, that's right. 2W. 2W. You have to go a distance A along the rod, and it's a vertical force. Vertical means tall. So we can move sine. Security sine. Beta is equal to 0. Now you can divide both by 2WA. Even you can divide everything by 2WA cos beta. This will be 1. This will be tan beta. Hmm. But I'll do it in 2 steps. Huh? I'll first divide it by 2WA. Now divide everything by cos beta while taking this to the other side. So beta is pi by 4. The reason is that it is an acute angle. Practically, it's an acute angle. Right? Now, resolve forces, considering the stability or the equilibrium of BC, I'll do it the other way around. X minus W, there are only two forces. If you resolve vertically, you get Y minus 2W is 0. So that's it. So the horizontal. Horizontal one is X. X is what? X is W. Right. Now we can go for this one. We'll take the moment about A. I'll do it here. Sorry. Considering the stability of AB. Now there are three forces, right? If you take the moment, if you take it in this way, both X and Y are in positive sense, like this way. So X is positive, Y is positive, and W is negative. Minus W is 0. For this force, you have to move to a distance of 2a. Horizontal means miti, idhar cos. Kam karo? This alpha, so you have to attach cos 6. 2a cos 6. Sorry, cos alpha. Y. Sorry. This way y is negative. I am sorry. Y is negative. This way the force is in the opposite direction. Again, you have to move a distance 2a. It's a vertical force, so sine alpha. For W, you have to move a distance of A, right? Vertical force, sine alpha. Now divide everything by cos alpha, A cos alpha. Before that, you have to substitute the values. X is W. I'll divide everything by A cos alpha while substituting the values, the constant, not the constants, the expressions for X and Y. I divide everything by A cos alpha. So this is gone. A cos alpha. So these 2 times 2W. Y is W. No, Y is 2W. Times 2. I divide it by A cos alpha. It will give you tan alpha. When I divide this by A cos alpha, I get tan alpha. Right? I have divided everything by A cos alpha. Now, you can divide everything by W. 2 minus 4 tan alpha minus tan alpha is 0. So 2 is 5 tan alpha. Alpha is the inverse of this, 205. I think I have to include one more step. Yeah, you can do that because alpha is an acute angle. Right? Okay, you do that. It's very similar. The weight of BC was changed to W. Yeah, I have changed this one to W. Paper कितने मेरे दिन आपकी गुड़ा paper सुलह तो बुना कुल निकम में W2 WL योगी निकम मगर मेरे लिए मेरे P ओले numbers सुलह तो my problem सही रहती है नुक्को में I erase this. I can use the same diagram. Now it's W. By considering the equilibrium of BC, you can take the moment beta. Shall I erase this part? Right. Now in this problem, again you have to do the same thing. You can take the moment about B because we need to find beta. Tan beta, you can take tan beta, you can find tan beta if you resolve forces. And at the same time, if you try to resolve forces, you will get x and y in the equation. So this is the only option you have. So there are two forces. For the horizontal one, it is in the positive direction. The distance we have to go along the road is 2a. It's a horizontal force, therefore it should be cos beta. This negative W times the distance we have to go, move along the road BC to meet this force is A. And it's a vertical force, therefore sine beta. Don't cancel anything. When you apply a principle, in applied, you have to be very careful in that. Don't cancel W. Then the person who grades the paper can argue that the student doesn't know. The student has thought that W shouldn't be there. So you cannot don't do anything in this line. Don't cancel anything. In the next line, you can divide everything by WA. So when you divide it by WA, you get 2 cos beta minus sine beta. Now divide everything by cos beta and take this guy to the other side. So beta is tan inverse 2. Hmm. After that, you can resolve forces considering the equilibrium of BC. Then you can figure out x and y. Finally, take the moment of about A by considering the equilibrium of AB. All right. Now we can resolve forces by considering the equilibrium of this. So W is in this direction minus X. If you do it vertically, Y minus W is 0, Y is W. So the horizontal component is W as well as its vertical component. Now you can, considering the equilibrium of AB, now we need to find alpha. You cannot resolve forces here because it's attached to some point. We don't know what the exact forces acting at that point. Therefore, you can take the moment about A. That's the only thing you can do with that. So X is positive, Y and W are negative. The distance you have to go along the rod is 2A, right? Uh, and it's a horizontal force. Therefore, cos alpha, 2A cos alpha. Uh, for this next time Y, again 2A, but it's a vertical force, sine alpha. You have to move a distance A to meet W, and it's a vertical force. So A sine alpha. Now divide everything by A cos alpha. At the same time, you can substitute these. I'll substitute this 2W A cos alpha, 2W A sine alpha. Now here you can divide this by WA. Now divide everything by cos alpha. 2 is 2 tan alpha minus tan alpha is 0. So 2 is 3 tan alpha. Now from that you can say alpha is tan inverse 2 over 3. Practically alpha is an acute angle. So after this example, we'll take a break. After this one. This one means after the third one. Here we need to find P. To have that particular inclination, you have to find P. So P is unknown. But beta is given, right? So this is the answer. Same diagram, similar diagram. I mean, everything is the same, but P is unknown. You know the angle B. Now, angle B is given by this. Angle beta is given by this. Means tan beta is 4. So to use tan beta, you cannot resolve forces. By resolving forces, you cannot come up with anything. Therefore, you have to go for a moment. Now, we need to find P. That means P should be in that equation. However, you have to eliminate X and Y. To eliminate X and Y, you have to take the moment about B. Right? Then X and Y will not appear in the equation, leaving the only variable as P. Hopefully, we can use this. We don't know. We can use this, hopefully. So, again, window use kind of පුළුවන් වෙන්න තියලා තියෙනවා බැරි වෙන්න තියලා තියෙනවා but this is the best bit we have. කියන්නේ කරන්න තියෙන හොඳම දේ මේක. ඒනකොට අපිට ෂුවර් නෑ tan beta use කරන්න පුළුවන් වෙයිද කියලා. We don't know that. Right, but for the time being the best bit is to take uh, the moment about beta. Once you know the value of P, once you know P, then you can, by resolving forces, you can find X and Y. Right? We'll erase this. You try it first. Then I'll do it for you. Then after that, we can take a break. You can take an interval and I'll go through this problem after the interval. One night, did it? Some of you have already taken the interval, right? But officially, I gave you an interval. I will do this problem because none of you have obtained the correct answer here. Right. First, you can find P. You can find P by taking the moment about B by considering the equilibrium of BC. So if you take the moment, P is a positive, P is in the positive sense. The distance is 2A. Since it's a horizontal force, it should be 2A cos beta. This way, it is negative W. Distance that you need to go along the rod is A, and it is a vertical force. Therefore, it is sine beta. Now, divide everything by 2A cos beta. You can take that to the other side. Tan beta over cos, sorry, sine beta over cos beta is tan beta. And tan beta is given. It is 4, which is 2W. Now find the horizontal and vertical components of the reaction on rod AB at joints B. You haven't done this part correctly. Now first we have to find X and Y. Hmm. So you can resolve forces. Still we consider the rod BC. X is P, where P is 2W. Vertical reactions. Y minus W is 0. Now usually the horizontal component of the reaction is 2W and vertical reaction is W. That's correct. However, in this particular problem, even last time the problem was like this. Find the vertical and horizontal components of the reaction on rod AB. Now, if somebody asks you to find the horizontal the horizontal components, it is just 2W. You cannot indicate the exact direction because the horizontal component on BC is in this direction. The horizontal component on AB is in the other direction. So you cannot in particular state the direction. If the horizontal component, if the horizontal component at the joint is asked, you cannot indicate the direction. You can say that it is W. Oh, sorry, here it is 2W. However, here in particular, you are asked to show this one. The reactions, vertical and horizontal components of the reactions on rod AB at joint B. So you have to look in the AB's point of view. Rod AB. On rod AB, it will be like this. You can give this using a diagram. Now you can show the particular directions on AB. These reactions are acting on AB and they are caused by the rod BC. Those reactions are there because of rod BC. And on the other hand, on rod BC, these are the reactions. They are in opposite directions. The make in AB nisa. Right? This is there because of rod AB. These two reactions are there because of rod AB. These two reactions are there because of rod BC. These are the reactions on AB. These are the reactions on BC. So in this case, we have to find the reactions on rod AB. So on AB, now you have to give the exact directions. Fortunately, these are positive. If you have a negative, if you have negative something, you have to reverse the direction, right? Now, in this particular case, x is in this direction. It is 2w. The vertical component is in the downward direction, and it is w. You have to indicate it like that. Because those reactions now have a particular direction. Early in the previous two problems, you were asked to find the horizontal component. You cannot indicate the direction because you have two different directions there. Hmm? It is just a horizontal component. It is 2w in the two previous problems. But in this particular case, if you are asked to find the reactions on rod AB, it should be these two. The reactions on rod BC should be these two. So the direction neck theorem. You can indicate it like this. So that's only mistake you have. Huh? Everything else is correct. Now show that tan alpha is 4/3. Now you can take a moment about A by considering the equilibrium of AB. There are three forces. X is positive. Y and W both are negative. For this force, you have to move a distance 2a and the angle is alpha. It's a horizontal force. So 2a cos alpha. For y, again, you have to move a length 2a, vertical force sine alpha. To this one, the distance is a, and it's a vertical force, so a sine alpha. Divide everything by a cos alpha. No, we have to substitute these two. W is, sorry, x is 2w. This is w. Now you can cancel terms, but don't cancel terms, in particularly in applied. Once you, after you apply a certain principle, don't do cancellations. Now you can do that. WA divided by WA. Right. Now you have 4 cos alpha. I'll divide everything by cos alpha. 4 minus 2 sine, 2 tan alpha minus tan alpha. Now take the inverse. Practically, it should be an acute angle. Here, I'll again explain this to you. Usually, if the reaction, the horizontal component is asked, if you are asked to find the horizontal component, it should be 2w. You cannot indicate a particular direction. It is like this. However, because it acts in both directions. However, in this particular problem, you are asked to find the horizontal and vertical reactions on rod AB. On AB. That means these two. These two are acting on AB because of BC. So you have to indicate these two directions. Magnitudes are insufficient. Huh? Magnitudes is directions in the you have to indicate these directions. They may deduct points because directions are not given in your answers. So draw a small diagram and indicate those two reactions. That would be sufficient. So you can come up with a sentence indicating these two. With W and 2W, you have to indicate the directions. Like W, like this the vertical component, this the horizontal component, like that you have to indicate the directions. In that particular sentence, you can indicate that. Indicate those two by using two arrows. W and 2W. But if you ask to find the reactions on BC, then they should be in the other way around, in the opposite directions. A sentence without indicates kandar. You have to understand that you are asked to find these two. You don't have to erase the sentence, just add these two, add the directions. The directions again, do since you have already inserted a sentence, rather than just writing W and 2W, sorry, you have horizontal is this, vertical is this. First indicate this one, then indicate the vertical component. The directions are necessary here. Otherwise, the direction is not necessary. If you are asked to find the horizontal component of the reaction at joint B, you cannot in particular say what the direction is. It acts in both directions. However, if the reactions on AB or the reaction on BC is asked, then you have to indicate the directions. Then may on AB ko may kahanne, these two. If you don't give the direction, they can mark it wrong or they can deduct some points. Zero dinne, no points get deducted. So half with rogidi. A sentence no mehmalian. Right. I think other parts are correct. Now, this 2019 question paper, problem 15, I can remember part A or part B, whatever. The lengths are given. No, I am sorry, the lengths are given. I haven't, I have forgotten to write that. A. The lengths are given. Even though they are not given, you get the same answer. You can take any length. But the rods are uniform. Uniform means the center of gravity is at the midpoint. After that, you try this. I'll do that for you. Since you are asked to find the reactions at this point, you have to detach this and mark the appropriate reactions, and then you have to show that tan alpha is this. Here, you are asked to find the reaction by rod AB on BC. Yeah? By the rod AB on rod BC. That means the forces acting on this rod. You take down the problem, then I do it for you. You can see that the horizontal component of this force is in this direction. Therefore, x should be in this way. Since 2w is in the downward direction, it should be this. Now, this is x, this is y. First, you need to find beta. So, what should you do? You have to write some, you have to come up with some equation, but resolving doesn't help much. So, you can take a moment about B. Then you can get rid of these two. All the forces are known. The only unknown thing is beta. So, you should be able to find beta. But here it's easy. Why? Because if you take the moment about B, the perpendicular distance to this force is exactly 2a, right? This is straight, I mean, perpendicular distance. Perpendicular 2a, just 2a. We don't have to apply that SV method to do that. Huh? So this is a positive force. The perpendicular distance is 2a. For this, it is 2w. It's in the negative direction. The length is what? You should go, you should move a length A along the rod, and it's a vertical force. Therefore, it is sine beta. You can find beta from this. After that, you need to figure out the angles here because you want to resolve these forces. This is beta. Is that correct? No, this is beta. Sorry, this is beta. Is it the letter is it? So this should be 90 minus beta. That means this is beta. Now resolving forces is not a big deal once you know the value of beta. So you can find x and y. Here you are asked to find these two. The reactions on CB, right? Means these two. Hmm? So it indicate the directions. Then you can you take a moment about t to find tan alpha. Right? You try to do it. Yeah, sorry. Right. Uh, Now this is WA. I'll divide it by A. Here you have 2W sine beta. You can take that to the other side. At the same time, you can divide this by W. So sine beta is half. Now, you have to find X and Y. If you resolve forces vertically, or which way? Horizontally, X is in this side. This is a vertical force. The horizontal component of this force is W over 2 cos beta. It's in the other direction. Beta is 60. So 5 by 6, sorry, 30, 30. So it's square root 3 over 2. If you resolve forces vertically, y is in this side, 2w is in the opposite side. This is w over 2 cos, sine 9, sine beta, right? W over 2 sine beta plus. So y is 2w minus w over 2 sine pi by 6, which is half. Which is W over 4, which gives you 7W over 4. Now you are asked to find the horizontal and vertical components of the reactions on BC by AB, right? On BC, I think it's on BC. Hold on. Reaction by reactions, huh? Components of the reaction by rod AB on BC. So how the rod BC feels the reaction. So that means we have to indicate these directions. Magnitudes are fine, but you have to find the directions as well. You have to indicate the directions as well. These two are the directions. Hmm. So it is like this. Hmm. If you are asked to find the horizontal component of the joint, you cannot exactly say which direction it is. You can just indicate the magnitude. But here, you are asked to find the uh, reaction, the horizontal and vertical components of the reaction on BC. On BC means how the BC feels. This is due to rod AB. So you need to indicate these two directions. Into Kalingatta Vishesha XY. So the X left side components are. X is square root 3 W over 4. In fact, the components on BC, then you can take the moment about A to find alpha. You can do that. It's not a big deal. Usually 12 minutes or 13 minutes are allocated for this problem. You can do it in real quick. Now take AB. Take the moment about A. I'm sitting a little far away, but it's okay. There are three forces. X is positive, Y and W are negative. If you take the moment in the indicated direction, X is positive, W is negative, Y is negative. Now X is acting at this point. The distance from A to this point along the road is 2A. It's a horizontal force. So 2A cos alpha. By the same argument, W is acting at this point. The distance from A to this point along the road A is simple A, but it's a vertical force. So should be sine alpha. This 2A sine alpha. Substitute the values. X is square root 3 over 4 W. I'll divide everything by A cos alpha. Why is this? Now divide everything by W. Now you can add these two. This 3.5, this is 1. So altogether 4.5. So W means 9 over 2. Right. We'll do one more example. Right. Now, this is something we need to learn pertaining to the symmetric frameworks. If you are taking this down, I think you are done with this, right? Can I erase this? No. Right. Now, in this particular framework, this is the only thing only joint you can detach. Because here another rod is attached to this. Therefore, you cannot detach this because even though you detach that, you don't know how to mark the forces. Hmm. If there are only two connected rods at a joint, then you can detach. Otherwise, you cannot. Now here you can detach this, so you will end up with something like this. Now how to indicate these forces? You can take these two as x. What about the vertical components? If you consider the symmetry, it should be like this. Right? Because it should be symmetric about this line. This is the line of symmetry. Now look, if you do that, it violates the stability. Right? Now this is not stable. Therefore, 2y should be 0. Because otherwise the joint should move in this direction. Hmm. So 2y should be 0, then y is 0. But usually when you have symmetry and the stability or equilibrium, you give priority to equilibrium. Therefore, you don't use symmetry when you indicate the diagram, indicate the forces in the diagram. So since the reaction that this rod feels is exactly the opposite of that, like we used to do, you have to indicate y like this. Now these two should be symmetric. Then you impose the symmetry. First you prioritize the equilibrium. Now you impose the symmetry. If it is symmetric, what should happen now? It is like, say, this is y. This is exactly in the opposite direction. Therefore, it is in fact minus y. So y should be equal to minus y if it is symmetric. So by symmetry, y should be equal to minus y. These two should be equal. Then you get 2y is equal to 0. Eventually, you get y is equal to 0. But you don't have to write all these steps. You can straight away come from here to there. Next time when you encounter something like that, after indicating the forces like this, you can straight away claim that y is equal to 0. And you don't have to go through, I mean, it is not expected to go through these two steps. Hmm? Right. Uh, Usually, one method is that you can impose symmetry first. Sorry, you can consider symmetry first and indicate y in the other direction. Then you can impose equilibrium. However, when it comes to statics, equilibrium is more important than the symmetry. Therefore, you indicate the diagram using equilibrium. I mean, using the principles of equilibrium. Therefore, this force should act in the opposite direction of the other force. However, then you impose symmetry. By imposing symmetry, these two should be equal. So these two are equal. It gives you 2y is equal to 0, and eventually y is equal to 0. But in actual, when you're doing a problem by symmetry, you can straight away claim that y is equal to 0. Right? So we'll do one example. If you want, we can do the same thing. Yeah. Rod BD is there just to hold the other parts back, like it simply pushes these rods away, right? Because of the weight, since these are smoothly hinged, they will like commit. They will try to be in a straight line. So this one hold those things back by pushing them away because it pushes. There's a thrust in the rod, right? So this is a problem. You can take this as alpha. This is a rhombus. So you cannot detach these two joints. So you will be, this is the best thing you can do. Now, in fact, this is pulled. So the force is like that. This direction should be correct. Huh? Make it tallu karana push karla tira better. Therefore, that should be indicated correctly. Now, A, B, C, D. There are no free roads in this problem. If you take this road, it is attached to the other parts at B. Therefore, you cannot resolve forces. Free road free. Uh, Therefore, the only thing you can do, you cannot even take a moment about this point because the forces acting on BC at B are unknown. Hmm. Therefore, the only thing you can do is to take a moment about B. Right? That's the only thing you can do. But before that, now there are three things we can find. We have to find T, X, and Y. So you can come up with one equation. You can come up with the second equation by considering this part, ABC. Hmm. However, still A is attached to the other parts. Therefore, if you take ABC, you cannot resolve forces. Hmm. This is something you know, not so you don't worry about this force. It is something you already know. The problem here is that there are some unknown forces. We don't know what they are, how they act on AB. Therefore, we cannot resolve forces. We cannot even take moments about these points. If you take the part, I mean, the combination of rods AB and BC, this ABC, the only thing you can do is to take a moment about A. So there are two things you can do. Take a moment about B by considering BC. Similarly, you can take a moment about A by considering the equilibrium of ABC. You cannot take AB because both parts are attached. AB to move current, if you take ABC, one end is free. Then you can take the moment about A. Hmm. So you have two equations, three unknowns. But only thing is that you can, by considering symmetry, you can find y. Y is equal to 0. Right? So by symmetry, y is equal to 0. That's a great help. Now you can take them, sorry, let's mark the distances. You can come up with an equation for this one, but it is the same as this because it's symmetric. So we'll take a moment about B, considering the equilibrium of BC, we can take a moment about B. Now, even though y is 0, you include that term in the equation. Na? So if you take the moment, y is positive, x is also positive. However, w is negative. Look, right? So x and y are positive. Now, for x, you have to go along the road a distance to a. It's a horizontal force, cos alpha. Easy, right? For x, distance to a, cos alpha. For y, again, the distance is 2a, it's a vertical force, so sine alpha. For w, you have to go along a distance a to meet w, and it's a vertical force, so sine alpha. Now y is 0, you can indicate that here. Now divide everything by a cos alpha. You can take that to the other side. You can divide it by 2a cos alpha. So W over 2 tan alpha. So that's reaction at C. Because vertical component is not there. This is the only reaction you have. A direction cannot be given because it's just a reaction. But if you are asked to find the reaction on BC at joint C, what is the reaction on BC? Then it should be this. You have to indicate the direction other than the magnitude. If you are asked to find the reaction on CD at joint C, it should be in the other way around, this way. ඒක ඇරෝ එකක් දෙන්න ඕන. මේක ඇරෝ එකක් ඕනේ නැහැ. ඇරෝ එකක් දෙන්න බෑ. ඒ ඇරෝ එකක් දුන්නොත් වැරදි මේකයි දෙපැත්තටම තියෙනවා. මේක ඇරෝ එකක් කියන්න බෑ. Right. Now you can take ABC, this part. But the only, if you take ABC, at this end it is free. It is detached. Even though it is detached at this point, it is attached to the other parts. Therefore, the only thing you can do is to take the moment about A. Right? There are several forces here. 1, 2, 3, 4, 5. Okay, if you take W, it is in this direction. This W is also in the same direction. W plus W. What else? T. If you take the moment in this way, T is in this. You cannot take this one. This is the force applied to this combination. So you have to take this one. It's in the opposite direction. So minus T. What else? X and Y. If you take it in this way, X is positive. You can ignore Y because Y is acting along this line, center line. It goes through A. Therefore, you can ignore this one because it goes through A. But you have to take this X. It is plus X. Since it is in equilibrium, it is 0. Now, what is the distance? The distance is A along the rod, and it's a vertical force. Sine. A sine alpha. For this one, even though you have to go along these roads, you have to go a distance 3A. With the first 2A, you will go away. With the third A, you will come back. Therefore, it's a minus effect, negative effect. Therefore, eventually it is A because both are in the same line. So same distance. Huh? So this A sine alpha, because it's a vertical force. T, you have to go a distance of 2A to meet T along this road. Its angle is alpha with the downward vertical direction. Therefore, it is 2A, but it's a horizontal force. Therefore, cos alpha. X is horizontal, but the distance you have to come is 4A. It is not going, coming back, because look, if you mark a horizontal force there, and if you mark another force, look, when you move away, the force will go away. With 3A, it is here. With 4A, it is here. It goes away. But here it is coming back with the vertical force. Right. So for A, horizontal force, so it's cos alpha. X is known, X is W over 2 tan alpha. Mm, we can substitute that. At the same time, we can divide by A if you want. So W A sin alpha, W A sin alpha. You can add those two. 2W sin alpha. I divide it by A. Then you have minus. I can take that to the other side. T 2T cos alpha. I'm dividing everything by A. Now here, everything is positive, right? Yes. X is W over 2 tan alpha. Then you have another 4A cos alpha, but I am dividing this by A. So 4 cos alpha. Now divide everything by cos alpha or 2 cos alpha. Anyway, I'll divide this by, you can simplify it like that. Now you can divide everything by 2 cos alpha. When you divide this by 2 and cos alpha, you get W tan alpha. When you divide this by 2, this will go away. When you divide by cos alpha, this will go away, leaving W tan alpha there. When you divide this by 2 cos alpha, you get T. Right? Okay, you take that down. In the second problem, these two are equal to 3W. So again, it's very similar. By symmetry, it's y is equal to 0. When you write the first equation, when you take the moment, it's as before, but this force is 3W. So the reaction has only a horizontal component. It is 3W tan alpha over 2. The second problem. First current will I think I'll erase this. Now you take the moment about A. So there are four forces. W is in the positive direction. 3W is also in the positive direction. X is also in the positive direction. And T is in the negative direction. For W, it's, the distance is A sine alpha because it's a vertical force. 3W. It is also in the same line. So it is again A sine alpha. For X, you have to move a distance 4A along the rods. Each rod has, is making alpha with the vertical direction. Since it's horizontal, it should be cos alpha, 4A cos alpha. And finally, this one, it's 2A cos alpha because T is a horizontal force. You can divide this by A cos alpha. These two can be added, but we'll divide it by A cos alpha. Now substitute what you have for X. Now you can add these two. You get 4W tan alpha, and this is 6. These two will go away to 2 times 3 is 6. 6 plus 4, 10. W is missing. Sorry. So T is 5W tan alpha. We can do this as the last problem. This is W1. Light rod means its weight is negligible. It doesn't carry a weight. Sorry, it doesn't have a weight. And here two weights are attached to these points. So that means you cannot remove them. You cannot detach them. The only joint you can detach is the joint C. So you can. So in this is a past paper question. You need to find T. That's all what you have to do. You have to find T. The thrust in the light rod. So there are, okay, what should you do? There are three things you need, three unknowns, X, Y, and T. Hmm. Uh, you can get rid of Y easily. You can find Y. You cannot get rid of Y, but you can find Y. By symmetry, Y is equal to 0. Hmm. Then what are the equations you can obtain? You can consider BC, right? By considering BC, you can take moments about B, because this is detached. This is attached. Because of this W2, you cannot remove. Hmm. Because we exactly don't know how the uh, forces are acting on BC itself. Now take this. You cannot apply anything because both sides are attached. But if you take ABC, the combination, ABC, this compound or this pair of rods, this side is detached, but this side is attached. Therefore, the only thing you can do is that you can take a moment about A by considering the equilibrium of ABC. But unfortunately, unlike the last time, because last time when you take the moment about B, T will go away. T will not appear in the equation. But in this case, you can't help because always you get T and X. In this equation, you get T and X. In the second equation also, you get T and X. You simultaneously solve them. And you don't have to find X. You need to find T only. Right? So when you get simultaneous equations, you try to eliminate X. Otherwise, if you try, you can find X, but it takes more time. So straight away, try to eliminate X and find T. Hmm? You try it. It won't be difficult. It won't be very difficult. But by symmetry, Y is 0. Even though y is 0, when you take the moment about B, you include that. When you take the moment about A, it will go away because y is acting along AC or CA, whatever. Y is 0, but its line of action is along AC. Therefore, about A, its moment is 0. Therefore, you can ignore, you don't have to include that in the second equation. However, in the first equation, it will appear, but you can substitute 0 after that. You have altogether one, two, three, four forces in the first equation. Hmm. Take the moment about B. Next time, take the moment about T. Try to do it. I'll give you the answer. In fact, in the problem, T is given. A show it should be. It's like a show that something. Huh? It should be like this. T should be that. Right, I'll do it for you. Now y is equal to 0. Right. I'll take the moment about B. So if I take it like this, T is negative. W1 is also negative. Y and X are positive. The perpendicular distance here is A, and this horizontal force, A cos theta. For W1, it is 2A, it's A sine theta because it's a vertical force. X is a horizontal force and the distance is 2A. Y is a vertical force and it is sine theta for this 0. Now you can write X in terms of T. Since you want to find T, in the next equation also you get T and X. Now you should be able to replace X by T. At the same time, you can divide this by cos theta, A cos theta. So it is, I take T, W1 tan theta, 2X. I don't have to find X because in the next equation I get 4X because the distance is 4A cos theta. Now take the moment about A for ABC. There will be how many forces? 1, 2, 3, 4, 5, 6. But this will disappear because it will go through A. W1 is positive. This one is also positive. Same line of action. W2 is also positive. Uh, T is negative. X is positive. W1 positive, this is positive, this is positive. X is positive, T is negative. Distances are, this is A sine theta because it's a vertical force. Same line of action, this is also A sine theta. This is 2A sine theta. Because the length you have to go along the rod AB is 2A. For X, you have to go along these roads a length 4A. A. So it is 4A cos theta. For T, it is 3A cos theta. It's a horizontal force. Now divide everything by A cos theta. This is W1 tan theta. If you divide everything by A cos theta, this is W1 tan theta. This is W2 tan theta. This is 4x. A cos, if you divide it by A cos theta, you get 4x. Minus 3t. Okay. Now for 2x, I'll substitute this. Oh, you can simultaneously solve them. That's also one possibility. So 2w1 tan theta plus 2w2 tan theta. I'll substitute this for 4x, 2x. You can write this as 2 times 2x. 2x is this. Right? Because this is 2 times 2x. I have substituted that. So 2t, that is 3t. If you take this 2t, it will be t. This side you have 2w1 tan theta, 2w1 tan theta. You get 4w1 tan theta. Plus this is 2w2 tan theta. You can pull out 2 as well as tan theta. So you get 2w1 plus w2. Teen අපි හොයන්න ඕනේ ඒතර x කියන එක තමයි අයින් කරන්න ඕනේ. හින්දා x තමයි you have to make x the subject. මේකට දාන්න ඕනේ. එහෙම නැත්නම් 2x minus t වලට equation එක ගන්නවා. You get another equation for 4x minus 3t and solve them simultaneously. That's also possible. Right. Right. Mhm. But the time allocation is like 12 minutes, so more than that, 13 minutes, so probably more. But you can do it in real quick. This kind of time save, you can save time if you do this problem. Stat is also something like that, statistics. Right. So I'll see you next Tuesday, on a Friday paper is on next Tuesday. We can start both. We can start both. We'll start relative velocity. In the morning session, I'll do relative velocity. I'll do little bit of this. You bring 2 books, huh? For the relative velocity, you bring a new one because it's a long section. In this section, we are like halfway through now. Probably in a couple of days, we can finish this. Okay. So I'll see you on Friday for the paper, and then next Tuesday, we'll start relative velocity.